Hello guys, I'm going to talk about Einstein's special theory of relativity. This paper was published in 1914 and opposed many of the previously held beliefs. For example, Newton had said that momentum is equal to mass into velocity, but Einstein said this was wrong. He said that momentum is equal to mass into velocity whole divided by 1 minus v squared by c squared. I know this makes stuff pretty complicated, but this has been shown to be the most realistic form of momentum. Einstein based his theory on two postulates. A postulate is a statement that is known to be true and doesn't require any proof. So, the first postulate was that all inertial frame of reference have the same physical laws, be it your house or the space station. All places have the same physical laws. The second postulate was that in all inertial frames of reference, the speed of light is always c. For example, there's a spaceship traveling at 1000 meters per second and it shoots a beam of light. This beam of light speed is not c plus 1000, it's still c. So moving on, relativity means that every object in the universe moves in reference to another object. An object is always at rest relative to itself. An object in the universe has velocity, acceleration, etc. relative to another object. Okay, let's see an example. There is a random point on the sky. When I say sky, I mean a point where the Earth's gravitational field is in range. There is a box, and inside the box, there is a girl. You all know that acceleration due to free fall is 9.8 meters per second square. So the girl is inside the box and she's falling freely at 9.8 meters per second square. For the girl, she doesn't know that she's falling. She feels that gravity doesn't act on her anymore. It would kind of feel like she's floating in the sky and nothing is acting on her. But to the Earth, it'll feel like she's coming towards it at 9.8 meters per second square. Now that we've established velocity and acceleration to be relative, what about time and the size of an object? Believe it or not, those things are relative too. Let's take a look at time. We are going to do a thought experiment. Imagine there's a mirror and you are standing before it. Let the distance between you and the mirror be t, and the time taken for a light pulse to start from you, go to the mirror and come back is 2d by c. Let the time be delta t naught since you're at rest. There is your friend who's moving at velocity u. So the distance between you and your friend is u delta t by 2, since delta t is the round trip of the light. So the distance for the light to go to the mirror is L. So by the Pythagorean theorem, L squared is equal to u delta t by 2 the whole squared plus d squared. Also, 2L by c is equal to delta t. We replace L from our previous equation. We get delta t is equal to 2 by c root of u delta t squared by 4 plus d squared. Replacing d from our first equation, we get delta t is equal to 2 by c root of u delta t squared by 4 plus c delta t naught the whole square divided by 4. After we rearrange the terms a bit here and there, we end up with delta t naught is equal to delta t times root of 1 minus u square by c square. So that's about time. Let's look at the size of an object. Imagine a stick of length L naught at rest. It has a mirror on one end and a source of light on another. So the time t naught taken for a light pulse to reach the mirror and come back to the source would be 2L naught by c. Let's say the object is moving. When the time taken for a light pulse to go to the forward trip will be different from the time taken for the backward trip. So let the total time be delta t, which is the sum of delta t1 and delta t2. For the forward trip, delta t1 is equal to L divided by c minus u. For the backward trip, delta t2 is equal to L divided by c plus u. Adding them up to get delta t, we get 2L by c times 1 minus u square by c square. Substitute these values in the time dilation formula, we get L is equal to L naught times root of 1 minus u square by c square. What would I like to say here is this was not the way Einstein proved this equation. There are so many ways to prove so many equations, but I find this method to be quite simple and hassle-free. When Einstein was a teenager, he used to daydream about what would happen if he traveled at the speed of light and looked at the clock tower at the distance. He saw that time would appear to have stopped because the light of the clock cannot reach him as they both are traveling at the same speed. But there is one major flaw in his thinking. Guess what? You got 10 seconds. That's because we cannot travel at the speed of light. We can prove that with the length contraction formula. This is a meter scale, and this is a guy whose height is 1 meter. When he travels at 0.1 times the speed of light, his height becomes 0.99 meters. At 0.2 times the speed of light, it becomes 0.97 meters. At 0.3 times the speed of light, it becomes 0.95 meters. 0.5 times the speed of light, it is 0.86 meters. 0.8 times the speed of light, it's 0.6 meters. At 0.9 times the speed of light, it's 0.44 meters. And if he travels at the speed of light, his length becomes 0, which is impossible because matter cannot cease to exist. Since many formulas have this particular term, we usually write this term as 1 divided by gamma. So the momentum would be equal to gamma times mass into velocity, and force would be equal to gamma cubed into mass into acceleration. This does not mean that calculus is wrong or anything. It is just that he didn't choose the right upper limit for integration. Newton assumed velocity's limit to be infinity, whereas Einstein found it out to be c. So that's it, guys. Thanks for watching.